Good morning. How are you guys? How are you?
So good, sir.
Good. Practicing or learning everything?
No, no, practicing.
Practicing.
Yeah.
Who is the other guy? Shubham?
Oh, yes.
Shubham bhi bol raha hai.
So how are you, sir?
Good, good. So, okay. Hindi, in the series of computer vision, this is the architectures is the pioneer in the community, data science, computer engineer, computer vision community. The pioneer architecture. Now, let us see now latest improvements on the computer vision is by using ResNet. By using ResNet. ResNet is nothing but residual network. What is this? Residual network. This is what very most important. The the object tracking and object detection. The powerful algorithm used by ResNet. ResNet and more thing is efficient net. Lot more thing than in exception inception network. There are a lot more things they use the residual networks. ResNet stands for residual network. It was a very complicated architecture, and I will demystify today as much as very simple language and very easy to understand by using not more any technical stuff. I'll try to maximize your understanding by our general explanation. Anybody having the idea of ResNet? Anybody know about ResNets? If anybody know, please unmute yourself and let's discuss what the extent you know. Who is this? Okay. Sagar, you know ResNet? Anybody having the idea about ResNet? Yes. Tell me, Sagar, what do you know about ResNet? Okay, it is built by small residual block. What is the meaning of residual block and how this will improve? Hmm? Okay, meaning I don't know, sir. Okay. Okay, sir. Let me explain you guys what residual block. Meenakshi, any idea about residual block? Yes. Any idea? No idea. No, there is a one mapping function will be there. Okay. Now let us deep dive into theory behind it and not theory, the intuition behind it, the exact story, what is happening in the neural network, rest network. Let us assume, let us very slowly we should understand. Okay, rest net stands for let's go on mute. Residual nets. Residual are identity networks, identity blocks. But let us imagine there is an X. You wanted to make this to learn your application. You are passing through serial number of layers, and it is able to generalize it. F of x. This is the mapping function. Mapping function f of x equal to x. So it means that your model is good. Your model is good. So what we concluded so far, number of layers increases, model able to learn. So till this point, clear number of layers. If you are clear, type one layer because we wanted to understand from very beginning, very basic of this. Okay. Now, what is happening if you increase the length of a network? It will do good at some iterations, and then it, the error rate will increase. This is what very practical scenario. I'm not telling you for the theory. Okay, what is happening? For this theory? If this is a error rate, this is called iterations. So usually, as a paper in a book, this is what happens. You read. But in a reality, what is going to happen? You believe me or not? Once the uh, once the layer increases, my error will go this way. This is reality of machine learning. This is what reality of a deep learning. Number of iterations increases. Sorry. Here is error. Here iterations. Here iterations are increasing. My error is not converging. This is what very clear. This is what the reality of a picture. Seriously, believe me, this will happen for any model. So what is it now? What is the concept now? Hmm? Now this is the scenario for any neural networks. So for this, till this. Till this, you understood, right? Number of layers increases the complexity of a model. Also, it degrades the performance. If you are understood this concept, type degrade. If you are not understood, let me know and explain you. If you are understood the concept, let me know. Degrading. So now here, now how to solve this? How to solve this kind of problem? The my neural network not only 10 layers, 20 layers, 30 layers. It may go 50, 100, 500 layers also. So in this case, how this will be solving? How the problem can be solved? And what will be the issue? Whenever you are whenever I pass the input to the layers, I will never get same input after some operations. So there is a reduction of a image, reduction in features. There are a lot more issues. So how do we solve? How do we solve this issue? How do we solve this issue? Right. The concept we introduce here to resolve the model degradations, we introduce concept called ResNets. Nothing but residual nets. How residual nets works? Chalo, let's try to understand this concept. So what are the issues? What is the challenges? What are the what is the things which we need to focus on the residual nets? Residual, right? So I have a input of x. I'm passing the input of x to the series of operations. Let us say this is weights. Again we multiply with weights. Here I have using a ReLU concept. Again I have a weights. I have a ReLU. Then here I'll be getting f of x. Here I am going to use the f of x. F of x is generalization function, so I'll use other color. So now what will happen? Skip connection or shortcut connection. Skip connection or shortcut connection. Here what is the value will be here? X, f of x. So my total will be here at this position, f of x will be x. So how this will help me? How this will help me in learning? This was a big question to me in my mind actually. This was the big question in my mind. Is this diagram is clear? This is called residual. This is called residual block or identity block. Identity block. So we are gonna deep dive into again. We are not gonna discuss further more. Okay? Hold on. We are gonna discuss. If you are clear about the residual block, type residual. If not, I'll explain you again. Okay. Ha. See, there is an A. Let us write in it this way. I have a X is my input. I am passing to the series layer. One is what the layers I am passing here? Linear activation. Then followed by ReLU. Then there is an operation. There is an again activation function. Here AL plus 1. If this is a AL, imagine this. This is an AL. Activation at L. So what I am doing? I am just skipping the I am just making one more connection. So I am making this to here. I am adding here. So what will be the final layer here? AL plus 1 plus AL. I'm again adding this entire value of AL and AL plus 1 here. Right. So if I use my activation function, So this is what they happening. So now I will say AL plus 1 equal to, what is the L plus 1? W weight of L plus 1, basically without neural network connection, into A of L, this L, plus B of L plus 1. This is what the weights at this position. When you apply the AL plus 1, so that L plus 1. So this will be here. And now what you are doing additionally, AL plus 1 equal to activation function and Z of L plus 2 plus A of L. We are adding the skip connection so that you have more parameters. More parameters. Now, this will solve the problem of vanishing gradient. Vanishing gradient. How? How is the question mark? Meenakshi, clear? Understood? Okay. Now, how this will work out? How this will help in the process? How this will work in the process? Now, we are coming here. Now, I am going back to the one example. How this will help in the solving of vanishing gradients. Guys, so far clear? If you are clear, type 1. This is the one of the complex architectures I ever seen and I ever worked. I will show you Aniket. Wait. We are not completed. I will show you that. Before that, let me explain. My next question. Why ResNet works? Why ResNet works? Here. Let us say X is my input. I feed this to big neural network. I get a activation of loss of L. Now, here I am taking X. Then I have a activation of L here out of this, our first layer. Then I have added some more layers to it. Then I am getting AL plus 2. Right? Is this clear? This is AL plus 1 and AL plus 2. This is what you clear. So what I am doing now here, I am just adding the skip connection. From here, I am just I am making skip connections to this, right? So now AL plus 2 equal to, what is the values I will be getting? I will be getting ReLU, or a G is activation function. So ZL plus 2, this activation function, plus AL. This is what, till this point is clear. I hope everybody is clear. Now let us see the situation here. ZL plus 2 will be, I can write it as this, activation function of W of L plus 2 into A of L plus 1 plus B of L plus 2, right, in plus A of L. This is what the whole equation. This equation. If equation is understood, type equation in the chat window. So that I want to make you engage so that you are following the lecture. That was the main motto about this complex architecture. If you know this architecture, seriously, you will become a different story. Can I explain AL plus 2 part? What is AL3? Where is AL3? AL only. This is L only. So now it is passing this activation of AL, Vaidehi. Then we are moving this one here AL plus 1 after this activation, after the work has been done on the one. Here it will come to AL plus 2, right? The next layer will be there will be an activation on AL plus 2. This is moving to here, this will pass, here it will be AL plus 1, here it will be moving to AL plus 2. Here there is no AL3, it's AL only. BL plus 2, right? Weights equal to, here the weights will equal to B at a B and a second instant, right? This one, right? This weights will be here. See, this activation function will be combination of at a second stage and L layer, second layer of second stage. That is what L plus 2 and L, this is what L plus 1. See, equation is try to understand how this will help us when I'll be making move from here. Here we have something called, now equation is changing, L plus 2 into A L plus 1 plus B L plus 2 plus A. When we use the equation is a regular in this architecture, regularization L1 and L2. What is L1 and L2? Guys, you need to tell me.
So it's a norm functions.
Why do we use norm function? Sita, why do we use norm functions?
To overcome problem of overfitting.
Ha. The Sagar, right? No, the Naveen, right?
Yes.
To overcome overfitting problem. Okay, excellent. So whenever you are using, because of your model is too heavy, and we are using the regularization to make it that fit, right? In this process, your weights becomes 0, right? and this will go vanish. But still you have a AL, the activation at layer, you will have this function, right? This value remains the same. When you are having the skip connection, when you make the connection is skip residual, so if you are vanishing gradient or if you are regular, you applied the regularization, but you have the still data, right? You will get the still data here. So this will help us to improve in the performance. Improve the performance. This is what the whole story about deep neural network. And one more thing, one more important point what we need to understand. I hope everybody is clear about this. If you are clear, type C. Type C, not one. Okay. Now here two takeaways. Naveen understood residual networks? I'll come Ankit now. Here key points. Point number one. Additional layer would not hurt the model performance. Okay. The additional layers would not hurt the model performance as regularization will skip over them if those layers were not useful. Not useful. The point number one. Point number two. The addition of new layers will be useful even the presence of regularization of weights of the layers will be non-zero, right? Will be non-zero, and model performance could improve the better, because when you are applying the regularization, some of the if you are using L1 and L2, whatever the way you choose, L2 will be weights should be close to zero or Naveen? I confused.
Sir, L2 regression towards 0.
Okay, 2 or 0.
Yes.
So this when you are making this weights to towards 0, the model performance would improve. And whenever it is happening, but still the model is trying to learn with previous connections, with the previous ones. So the both the way your RESTnet by using skip connections, it is able to learn the data perfectly. Learn the data perfectly. And now you see the skip the the main point here we need to understand. Your shortcut also learns the parameters. Learns also make it very easy for the block to learn the identity function. That is called identity function is called f of x. So the residuals are most important. In the residual network, there are the two blocks. One is identity block and convolutional block. We do apply on the. Now I'll show you the. Now we could see the here there is a network connection. Assuming that you have several layers, and in the residual step, you would not only pass the output of layer 1 and layer 2 and so on, but you also add the output of the layer 1 to the output of layer 2 by denoting f of x. So, however, your output will be f of x plus x. So, here we need to mention that your output to the layers. I'll see this will run it faster because I have yesterday and we are not going to run this. Okay. Now, these blocks we call it as a residual blocks. Residual blocks. Now let us see. The projection of this shortcut that doubles the number of filters. Projection of the shortcut doubles the number of filters. The first block is the linear projection for the residual link to expand the number of features. Here, the one of the most. Here we need to have the first groups, the defined groups. The first groups does not do any feature fueling of the projection of the blocks. It's sequentially, while subsequent groups is the feature fueling. The features pulling layer. Now you see here. ResNet, the inside of the ResNet group. Input, zero padding, stride, then zero padding, max pooling. Here, what is happening here? Dimensionality reduction. Dimensionality reduction happens here. Here, dimensionality reduction happen in the ResNet block. Now you see. Now you see here clearly we are adding this input to here. After this, bottleneck design. This is called bottleneck design. This is what convolutional one and one. We will talk what is convolutional one and one in tomorrow class. Why are we using 1, 1? How this will improve the performance? And we are using here. See here, this paper is called, in this paper, this is called convolutional 1, 1 is called dimensionality reduction. Again, convolutional 3.3, the number of features map will be increased. This is called dimensionality restoration. In a ResNet, there are two things that will happen. One is dimensionality reduction is happening, and other restoration is happening. So that model have enough features to it, enough features to learn from it. The last convolutional increase the number of features. So we need to define there are the two things, right? We need to have a identity block and convolutional block, right? By start saving the copy of input of the residual. So I'm just copying this to, I need to add it to other layer, right? So this I need to copy it. So input residual bottleneck. Then I have written the add to shortcuts. This is what I am adding the shortcut. Shortcut identity block. Now you see here reduce the filter size by 75. Again we have here is reducing, and also we are reducing the filter size here. So we are adding here. So in the this is called h of x. This is what, like, if it is this is x, this is f of x. So my final function will be f of x plus x. In this particular whole story, what is happening here? Restoration of an image plus degradation, reduces. This all happens in the residual block. Residual block. So the projection block, that is called convolutional block. Remember that input of the residual as the number of filters increased to 4x on the first block to match the number of filters on the output matrix. So what will happen now? This, when you wanted to add f of x to x, there should be dimensions should be same. Dimensions should be same. What happens when you do the serial operations to it? It will reduce the dimensions. So that was the reason we are doing the detection and restoration, so that when you add the shortcut connection to it, there won't be issue of dimensions. We cannot add the different dimensions, right? So this is what happens in the ResNet story. ResNet block. So we use the batch normalization to address the vanishing gradient. Renormalize and batch normalization. Again, we need to use the renormalization. So renormalization of pixel values after each convolutional. This is not happens in this. First we do the batch normalization. We are making the 0 to 1. After convolutional, again we are doing the renormalization. The whole process being introduced in the ResNets. These are one of the most powerful architectures in the world. Most powerful architecture. Rest of things you can read it. You can have a go through the architectures and understand. These are one of the most pioneer. They are used in RetinaNet. They are used in other trackings. Lot more areas. Now you see, reduce the filter size. These are the projection. No, yesterday I have tried to run this model. Guys, are you understood? Clear about ResNet? Clear about the ResNets? If you are clear about the ResNet, how it works, type ResNet. Meenakshi, understood or not understood? Vaidehi, Ash. Lokesh. Abba, super. I want you to practice today, and I will share you the ResNet code here. I will show you. I will show you the entire picture here. What happened in the ResNet story actually? ResNet comes into the pictures of. There is a flavor of three kinds of flavors: 50 layers, 101, and 152 layers. But most of the architectures uses the ResNet 50. So most of whenever I have read lot more papers on this ResNet, and we understood that we are we see the ResNet 50 block. Now try to understand. I'll try to explain you what is happening here. I am defining the ResNet here. We are not going to execute now today because it took me to complete 50 epochs. It took me to complete 50 epochs of around 4 hours, but system got crashed in between. I was see my last was this is what clearly overfitting. The clearly overfitting that 98 is the training accuracy and test accuracy is 68. So you need to train your model, or you need to increase the change the you need to do this some more additions. Now you see this. What is happening in the ResNets? We do definition of the ResNet. Here we have two blocks. ResNet have the two blocks. One is identity block. Identity block. And convolution block. Convolution block. Here identity block guys, stay here, don't go. I have something for you. We are gonna do some more things about multi-class labeling. I have done this. See here, multi-class labeling. Here I have done it actually. It also took entire. I have kept it for night actually. Yesterday night I have kept. I have ran this and I slept. I ran this and I slept. I have stored the output. I'll show you this project also. Today, this weekend, you have ResNet and this. With this, we'll complete the object. This one, what we can say, classifying of images. Next classes from Monday onward. There is no class will be on Saturday, Sundays going forward. We'll have a 5 days in a week. So we'll have the next week onwards the object tracking, object detections. Object classification is different and object detection is different. I'm going to explain you in a proper way that how the world is working with object detections. This I wanted to show you. Please stay on. Don't run. Okay. Identity block uses convolutional and also convolutional, right? Uses the convolutional. Now you see they construct the residual network for V2 version 2. So we have how many parameters we have? We have the groups, the number of filters and number of blocks. The list into the groups. And initial weight will be HE normal will be the normal weight we are going to assign now. Now self number of layers, input shape and number of classes. This particular definition is taking the this we are discussing about here. We are telling you to we are giving information for a system to add what is your input size? Input size and number of classes is going to print it. Number of classes is going to predict. Is going to predict. Right. Here. Here you can see the number of layers and input shape and number of classes. Here we are going to RESTnet will accept here. For why we are using here? RESTnet having the flavors of RESTnet has been implemented and 50 layer network, 50, 101 and 152 layers. Now you see, I am taking the input, I am passing it to the X and the layers. So this is what the input. Initiate the model. So I have the model equal to model plus input plus output. Okay. Now here come to the story here. Here we want to construct a stem convolutional group. Here this is called stem convolutional group. What we call this as a stem convolutional group, because then we have your residual. First we need to connect first we should have the stem. Guys, give me some time, and it's the pen. Okay, this is called the stem, right? This entire thing we need to build as a stem. Then after top of this we need to build the residual. Skip connection. Skip connections. So that's what we are going to do. Construct a stem group and the input vector. So I am passing it. This is what I am passing it. Zero padding, convolutional and max pooling. This is what convolutional, max pooling, zero padding. This is what I am doing it here. Construct a learner and execute with input learner. So list of the groups. How many groups I have? I can have n number of groups, right? I can have the n number of this kind of groups. After that, construct the residual block. What we need to do? We need to construct the residual group. So for this also we need the residual, right? This is called a skip connection, right? Residual group. We are going to create the residual group. That is called projection. So finally we are connecting the bottleneck with identity block. So we need to add all this with batch normalization, bottleneck layers, and dimensionality reduction. So again we add this to shortcut. X will be added to the shortcut, right? So here we are been using, this is building the, we need to spend good amount of time to understand the code here. Unfortunately, I will tell you the Monday on the transfer learning classes. Before that, I would like to cover some more architectures like inception, exception. So what is one more popular network we use for this computer vision? I'll do research on that. Then I'll tell you one more architecture in a deep. Then we go to the pre-trained models. Here we are trying to build identity block. Then we need to have a projection. Then finally this will be continued. Projection will be this. Projection, what is happening in the projection? We are constructing one by one and 3 by 3 convolutionals. Then construct a projection, increase the filters by match to the output block. So where we need to match the projection block to the output block, so that there will be adding to the shortcut. Add the projection shortcut to the output of the residuals. So here when we are building a classifier, we are making the final layers. This is what entire story of your neural network. How this works in life, entire story behind your convolutional neural network. I hope maybe this code will take some time, but at least you understood the Sagar darknet. No, please, I will not explain the darknet at all. I hate about the darknet, so that's why I'm not going to discuss about darknet. I'll never discuss about darknet. Stupid architecture in the world. I don't know who has written. Guys, you understood the ResNet now? By this now. Now let us see. I'm using the ResNet 50. Now I'm using the 50 layers. Now you can see the. I'm just running in the simple block. I execute till this only. I won't execute further because it takes me my lots of time. Now you see. Now, if you go above, how many layers you believe me? This much of bigger network. See how much big network is this? ResNet. Imagine no institute in the world will discuss the ResNet in this detail. Trust me. I have seen Insofi, I have seen Upgrade, I have seen everything. See how much big network is. It's going on. It's going. See how much big network is this? Because it's all combination of skip connections, everything. See how much big network is this? ResNet. So we are coming down. At least we need to train this at least like 100 epochs or 200 epochs to make your model to learn. Otherwise, it won't learn. Baapre. From here, how many layers? Baapre, I'm not gonna see now. This much of big. This much, I have a 26 millions, 2.6 million parameters. So now when I display this image, I'm saving it into the diagram. Right? When I see this. Can you see anything here? Guys, can you see network? Guys, you can able to see, right? Great. It's very great. Can you see? No, right? Now you see. Now you see here. There are a convolutional layer here. Again, there is a skip connection here. Can you able to see the skip connection for the first? Guys, am I making sense here?
Yeah, sir.
Clear? This is again one more residual block. This one more residual block. This is what one more residual block. We keep on doing this. Finally, see how our network is being improved. So finally, it will improve here. If I'm improving, it's getting fatal. Here we see the dense layer here. Flattening here, then dense. This is what the beauty of algorithm. Now you can see the structure, right? How to zoom in Mac? Anybody know? I don't know.
So Control Shift plus.
Huh?
Control Shift plus.
Okay. Now, can you see something? This one is we're not able to see right here. Okay. Now, what else we will see here? Convolutional layer. I am able to see, but you may not able to see this. So you can put this in the TensorFlow diagram. TensorFlow, that's tensor board, right? So we can where you can visualize the complete picture. So I wish you to run this at your end, not from my end. I'm not gonna run it. I'll gonna upload this and tell me your results. Run it for 100 epochs, and
Sir, how much time it will take, sir?
it take at least 5 to 6 hours.
Oh, ResNet 50 only takes 5 to 6 hours. Then what about ResNet 101?
So that was the reason we are not using GPU, right? We are using dedicated GPU. We are not using this our machines, right? We are
Yeah,
using the dedicated GPUs for this kind of process only, right?
yeah,
There is no, there is nothing in the computer vision world with straightforward or very simple. If you anticipate that is a simple, that's your mistake. That's your complete misunderstanding of computer vision. That was the reason evolutions of. I have downloaded this ResNet. I'll gonna explain now. The multi-class labeling. I'm coming to the go. I'm walking. Walk through here the multi-label thing because it took me 6 hours. This one also. Bapre in GPU. What this project is all about. I'll go to this directory and I'll show you. I'll run it for at least I can run it for 5 epochs and see. Okay, we will run this for 5 epochs. Then before that, we will gonna show you the something. This ResNet I have done only cipher dataset. Like whatever we are practicing here, we are using the cipher data. What data? This one only. Cipher 10 data. You can run it and let me know the results. That is what you give me the gift for me. That's it. Nothing more than this. You learn it and you explain the concepts to the other people in a different way. Okay. Now we will go to this multi-label, multi-image. How many heard about multi-label, multi-image? Naveen, have you heard about it? Naveen? There?
No, sir.
Multi-label. No?
No, sir. Identify very related variable. So here we are not applying.
Here multi-label. So I'm taking the MIML dataset. What dataset? I'm taking the MIML dataset, and here I'll show you the images of here. Random images. What this images is all about and how this project we are working. In a given image, we always seen that there is only one picture. We always will find only one object. Whereas in the multi-label, multi-labeling, multi-image concept, multi-label, multi-image. So far, you have seen image and it is been classifying cat, dog, or bike or ship. This is what we have seen the cases. Now, in a multi-class, in a given image, I'll be having two objects. So, or more than two objects. It has to classify bike, car, and ball. This is called multi-label, multi-class activity here. This is called the multi-label, multi-activity here. Right? Here in this particular example, I have multiples of data. Here I have the thousands of data where we have the different images, clear sky and everything. You can see the images, people, desert, like this. We have the data of this one. So here this is kind of the data we have. So when you go to the result, yesterday I have run this. I have result.csv. When you look at this CSV, I have desert, mountain, sea, sunset and trees. I'll go to the where it is predicted the both the classes here. And let me know the number of the image here where it is having two classes. Guys, help me out of finding. Okay, now diagram. Go on 1976 image. It's having two classes. Guys, can you see 1976 having two classes? Yes or no? Now, I'll go to 1976 image. I'll go to the Reaper. This also you can train for more longer period. And I have one more something for you, which we can done multi-image with 5 minutes. We don't need to do that. That also I'll show you now.
Sorry, search bar.
Huh?
Type in
Sorry?
search bar, sir. 1976.
Here, 1976. Here it is showing some different
matrix. Each column to consider mean find out data point to minus mean, data point to minus data. It's nothing but a variance. Nothing but a variance. So the T difference transfer then.
Now we
data system and then transpose chain and data.
Okay. Maybe this is the image because we are working out. Here we have a tree and sky. So what it is predicted here, when you see the result, 1976, right? (1976) trees, and it should predict trees and something. Trees and
Fifth column.
mountains. Okay, that is what it is able to predict here. Now the model needs to train actually. More we need to train the model actually. Here you can see 1989 image or 1990 image. 1990 image, trees and sea.
Sir, so should we drop that image or what to improve accuracy?
Sorry?
Can we drop that image to improve accuracy?
No, why are we dropping? I'm just seeing that we have executed yesterday and I'm validating the result.
Okay.
If you wanted to drop it, sir, we are. Yeah, which one? 1990, right? Naveen? Which one I have seen here?
12 divided by 3 and 10.
1976.
1989 and 1990. Here you can see two classes. 1989 and 1990. Oh. There is something that it is showing that a sky and trees. It is predicted as this green as a sky and this is a trees. So this model needs to be tuned actually. For Firemount tuned. Because when you see this accuracy is only 66. So its accuracy is 66. So it needs to be retrain the model to understand your classes. This also I will share you here. I'll upload into the Google Colab. This Colab, this data, right? You can download this data by this one, MIML, this one, Dropbox. You can download here from here, and you can store it. This is the data set for your this weekend class. You can download this data set and train this multi-class labeling for at least 100 epochs. Now I will go and show you something multi-class. Here we are using something called a tessellate image. Here, multi-label image classification. What we are doing here? Multi-label image classification. What are the things what we do here? It takes not more than 5 minutes. You see the magic here. You can use this data, this libraries for your any classifiers will do. Download the data set, install the Monk library. Install Monk libraries and train the multi-label classifier, run the inference on the multiple images, validate the train classifier, run the inference on the test database for the submission of the competition. If you can use this library and also you can submit for the here. Data set is here. We need to have the Amazon data set, the planet data set here. This is the planet data set. We have taken it. This sort of data. The data looks like this planet data. Here you can see the GIS data, right? So we are gonna run it on this. So first I am trying to get this. This also I will share here. I'll write it here. Import the data for the project. Then we have imported, right? So it's very simple, very simple. So we are unzipping it. Here, what we are doing here? We are doing unzipping. So see here, we are having the satellite and satellite classes. Test train labels.csv. When you go and download it, this is .labels.csv. Agriculture land, agriculture, bare ground, blooming, clear, cloudy, haze, road, everything. Now, when you this is what the multiple classes, and how do we do this way? This having the data, the training of data set with haze primary and agriculture and primary water. Here you could see there are the two classes here: agriculture and clear primary water, and clear primary agriculture, clear habitation, primary road. Here in this particular, you could see the multiple classes. Yes or no, guys?
Yes.
Yes or no?
Yes, sir.
Yes. So now, Lokesh, can you be able to see?
Yes, sir.
Now, what we are doing? We are in unzipping, right? We have unzipped. We are running it again.
1.5 GB file it is.
Yes, man.
So what happens if you use TPU instead of GPU?
CPU is there. We need to have some different settings.
Okay.